So the first section here, it's all about, is this a function? And if it is a function, is it a linear function? Okay, so remember that functions, there's a few different ways to tell, and linear means it forms a straight line. So the big thing about a function is that every input has exactly one output. Okay, so real quick, do you guys think that the first one is a function?
No.
Why not?
Because the x has an m.
Okay, so you have something correct. It is not linear because of the exponent. But if you put a number in for y, are you going to get a number out for x? Or no, sorry, number in for x, are you going to get a number out for y? Yes. Okay, if I put a 2 in, if I put a 4 in, I'm going to get a number in and I'm going to get a number out. Okay, that means it's a function. So yes.
But it's not linear.
Yes, that's right. It's a function. But not linear because x has an exponent.
Yes.
Second one, is it a function?
Yes.
How do we know?
Because there's numbers.
Okay, there's numbers. There's something that makes it a little bit easier when we have a graph because we can do what? Yeah, good job. The vertical line test. So if we drew vertical lines, every line would only cross the graph once. So yes, function. And the reason is because it passes the vertical line test, the VLT. Okay, but is it linear?
No.
No, how do we know?
There's negatives.
Because the line curves, that is correct. Okay, not linear because the line is not straight.
You say the line curve.
Sure, but I just want you to know that the important part is that it's a straight line or not a straight line.
So like, if there's a
If
question
you
like this,
were answering that as you said, that would be okay.
curve would be fine.
Yep. Okay, now I'm giving you information as a table. Okay, so now we have to look at the table. What things are you looking for in a table, do you guys think?
Constant change.
Okay, constant change. Just to be a function, does there have to be a constant change?
No.
No, but to be linear, there does. So let's take a look. Let's just look at our change. So from 2 to 4
It's 2.
2, 4 to 6, 2. Okay, what about over here?
-5.
-5.
Plus 5. Wait, what? No.
Yeah,
Oh.
0. And then -5. Okay, so first off, is there a constant change?
No.
No, so what does that mean?
It's not.
Not linear. Okay, so we know that it's not linear. And the reason is because the change isn't constant. Now, if this 0 had been a -5, we'd be good to go, but it's not. Now, the other question comes back, well, we know it's not linear, but is it a function?
Yeah.
And it is. Every input has an output. And even though the outputs are the same for 4 and 6, that's okay. As long as 4 didn't have 2 different y's, that's where we can't have it. So yes. And the reason is because every input has one output. Sorry, I know I didn't make the boxes huge.
I thought that was the only thing we're writing, so I kind of.
That's okay. Okay. What about the next one?
It is linear.
It's linear, okay. Is it a function?
Yes.
Yes. How do you know?
Because X and Y are on the side, and you can put numbers in for X and Y to get 10.
Sure. Okay. So yeah, you can actually compute this, you know. The other thing is that it doesn't break any of those rules. There's no exponents, there's no square roots, X and Y are being multiplied. And if you guys remember, you know how to graph this line already. So if you can graph it and we're graphing linear equations, you're good to go. So yes, a function. And one of the things about functions is they like to have you get y by itself. So that would be y equals negative 2x plus 10.
Wait, why is it negative 2?
Because I minus the 2x from each side. Okay, and yes, linear.
But why
Pat-
is it by itself?
No, it was on the other side with the 2x, so it was not by itself. Okay. Logan, the next one. Does this one look to be a function? Yeah. Do you know how to tell? Okay. Noah, how could we tell by looking at this if this is a function or not? The vertical line test. Yep. If I drew vertical lines across my graph, it only crosses my graph once.
What?
Okay. So yes, a function. Because it passes the vertical line test. Then the second part, is it linear?
No.
Yes.
Wait.
Okay, what does it mean to be linear? A straight line. So yes,
It's negative.
it could be negative though. Linear. Because it is a straight line. So it's a function because it passes the vertical line test. It's a linear because it's a straight line. Okay. The next one, we've got another table. Okay, Serenity, when we have a table, what types of things are we looking for? Constant change, so let's look. So 1 to 3, what do we get?
2.
2, 3 to 5,
2.
5 to 7? Okay, what about on the other side?
Negative 2.
Oh, but it went up, didn't it?
Close to.
Yep, plus 2, plus 2. Okay. Now, there's constants. They don't have to be exactly the same constant, but they were in this case, okay? So not only is this linear, but it's also a function. So yes, function. The reason why it's a function is because each x has only one y. And yes, linear, because x and y have constant changes. Okay, now I'm giving you a mapping diagram. I like mapping diagrams. What they do, these lines pair up. So like if you put the 10 in, you got a 2, the 3 in, you got a 3, the 5 in, you got a 4, the 5 in, you got a 7, the 7 in, you got a 5, the 2 in, you got a 5. So Drew, any idea about this? Okay. Aubrey. Okay. Maddie?
Like, tell you, if it's like.
Yeah, do you think it's a function?
I don't think it's, I don't know if it's really a difference, but the 5 I noticed, It has two different answers.
Yes, you are right on. Okay, so a 5, this one input can't have two different outputs. That doesn't work. Okay, so not a function. Because x5 has two different outputs. So two different numbers can go to the same answer, that's okay, but they can't go to two different numbers. And the example that I really use a lot is this x squared one. Okay, I can put in a -2 and I can get 4. I can put in a +2 and I can get 4. So my table or my mapping diagram would have a -2 and a +2 both go to the same answer. Okay, and that's okay. It's going to produce a parabola, so it's not going to be linear, but it is going to be a function. Yep, a function, but this one's not a function. It breaks the rules. Yep. Well, if it's not a function, it's not linear. It can't be linear. Okay. Okay. So this one right here, we have I want you guys to envision, we just talked about these yesterday, I believe. Does anyone know what this graph looks like? X equals 5.
No.
Okay. X equals 5 is going to cross the x-axis at +5. Like this. Do you think this is linear? No. Okay. So not linear. Why? Because actually not a function. Not a function. Because why? Yep, it fails the vertical line test.
Why, how?
Well, if you drew a vertical line here, it would touch every point all the time. The thing with the vertical line test is when you draw a vertical line, it can only hit the graph once. Where if I drew a line on this line, it would hit every single point. I want you to envision, like I'll have my ruler. So like on this one, my ruler slides along. Only one point of my ruler is hitting that graph. Okay, so that passes the vertical line test. This one is more of an obvious one. It passes the vertical line test. But if you come down here, every single point is hitting my ruler. That means it fails. Okay, yep, look at this one too. What about it? It doesn't pass the vertical line test, so it's not a function. Not a function because it fails the vertical line test. The thing is with this one, you have to know what that graph looks like in order to do the vertical line test. Okay. Okay, the last mapping diagram here. What do you think?
No.
Yeah, you're right. It is a function. Yes, function. Because each x only has one y. Now, I wouldn't ask you to be able to pick this out from a mapping diagram, but I know since the 4 and the 5 both go to the same number, it's not going to be linear, okay? So it's not linear, and I'll just say because 4 and 5 both
Why doesn't that work?
the same y? Well, if you were picturing this on a graph and you graphed it, it would make your graph like kind of come up. So it would be off the line. Okay. So it works for a function, but it's not linear. Okay. So the next section we talked about is rate of change or the slope. So the first one is meant to be kind of simple. Okay. What you have learned so far, you should be able to tell me what the slope of this line is without having to do anything. Okay, who's got it for me? I just want to know the slope of the line. Okay, Danica? Yep, so the slope though is just 1/2. Okay. Our equation is y equals mx plus b, where m is your slope. So if your equation is in that form and I said, hey, find your slope, you should just be able to tell me the answer. Okay, so don't make it any harder than it is. The second type of problem, we have to use something to find the slope. What are we going to use? We're not going to graph it. We practice this. This is the slope formula. y2 minus y1 over x2 minus x1. You name your ordered pairs, x1, y1, x2, y2. So if I put that in, I would have 4 minus 8 over -3 minus 6. Okay, -4 minus 8, or +4 minus 8 is a -4. -3 minus 6 is a -9. The only thing you have to do here is anytime you have a negative and a negative, you are going to change that to a positive.
So it goes x.
Y's over x's, rise over run.
So x1 y.
y2 minus y1 over x2 minus x1.
How would you know for the 6 and 8? How would you know which one's good?
The x in an ordered pair always comes first. Okay. Okay. The next one, we have a graph. Now to find your graph, you locate 2 points that intersect nicely, which we have noted there. And then what you do is you do the rise. So you go up or down. In this case, it's up. Yep, and you count 1, 2, 3, 4, and over right, which is 1, 2, 3. So your slope is 4/3.
It's okay if it's improper.
It is okay if it's improper.
Yeah, I make a mixed numbers.
Pardon?
You have to make it a mixed number.
No, please do not make it a mixed number, but make sure it's reduced. So if this was 8/6, you have to make sure you reduce it to 4/3. Okay. Okay. The next one, this is a group of friends go to a baseball game. They have to pay $10 to park and $25 for each ticket. What is the rate of change? Any ideas? Go ahead.
$25 for each ticket.
That's right. $25 per ticket. The rate of change can also be thought of as a unit rate. Okay. Every person that comes gets charged $25. Okay. Now the next one, we had in the chunk above, we had an x equals 5. So if we have an x equals 4 and you guys were envisioning this graph, yeah. Okay, so there's our graph. It's going to be a vertical line, just like in the other one, at -4. 1, 2, 3, 4. So what is the slope of a vertical line? Undefined. Okay. Okay. So Jerry is taking a 382-mile trip to visit a friend. If it takes him 11 hours to make the trip, what is his average rate of speed? Or rate of change, I should say. So rate of change, what do you guys think? Go ahead.
I'm thinking of like the other word problem. Is it 11 hours?
The answer is not as obvious in this one. We have to do something. So if you think of the rate of something, miles per hour, yes, miles per hour. Well, we know that his trip was 382 miles, right? And it took him 11 hours. How do I get the true miles per hour? You divide them. So I'm going to take 38 divided by 11, and I get 34.7. So he was not going very fast. So either he was driving really slow, or maybe he was like in a boat or something. So when you think of rate of change, think of it as like how fast something's happening. Okay? Or like how fast something adds up, that type of thing. Okay. The next one is just like the one above it. You're going to want to have x1, y1, x2, y2. And follow that formula. Y2 is 14 minus y1, which is 8. X2 is -2 minus x1, which is -2. So you have to be careful. Make sure that you follow your rules for addition and subtraction here. This actually becomes adding a positive. So 14 minus 8 is 6. -2 plus a 2 is 0. What is 6 divided by 0? Undefined.
I mean, defined.
Yep, it is not 0. And if you are unsure, you can do 0 divided by 6 and you will get 0. But if you did 6 divided by 0, it gives you this, divide by 0 error, which basically means you can't do it. So it is undefined. Okay, the next two, we are trying to find the slope by looking at a graph. So you want to find nice points. I think here, those look pretty nice, right? So did you find it? Yeah, so down 2, -2, right 1. You can write it as -2 over 1 or just -2. Okay. And then on the other one, find some nice points. This one is,
it's hard to see.
it is hard to see. I'll make sure I print your graph better or your test. So in this one, I just chose those two because I could see those. Yeah, so up 2 and then over 4. So the rise was 2, the run was 4. But what does 2/4 reduce to? Yeah, just make sure that you're reducing that. Okay, then the last one kind of ties back into the first one. If you know that the slope should be right there, can we get this one in slope-intercept form?
Yes.
What do we need to do?
Divide by 6.
Oh, close. Divide by 2. And just make sure you divide everything by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. What's our slope?
2.
No.
3.
3. Just the 3. Okay. Any questions about rate of change or slope? Yes. I actually am going to collect them before the quiz. So you can use them to study and you get to use your packets, but they will be collected before the quiz. Okay.
We'll be able to use our packets on.
You can use your packets. Yep. Well, like I said, I have made the quiz based off of my review. I made both of them last night and today. Okay. So the next section is finding the intercepts. Okay. So the intercept is where it crosses the x and y axis. So if I were looking at the graph here, this is your x-axis, this is your y-axis, remember? So my x-intercept is 2. So it's 2, 0. And your y-intercept is, crosses right here. So it's 0, -4. Whatever you do, don't put them together. Okay, that's a whole different point. The second part says, write the equation in the slope-intercept form. So I wanted to tie in our slope-intercept form. So you need the slope and the y-intercept. Well, we just found the y-intercept. What's that? -4. So that would be our y-intercept. And then we just practiced finding the slope. So how can we find the slope of that line? We could just count, right? Up 4 over 2. What does 4 over 2 reduce to? 4 over 2 is just 2. Yep. So my slope is 2. So remember that for slope intercept, you just need your slope and the intercept. Oh, sorry. Okay. Now, when we find the intercepts from an equation to graph, we use the cover-up method. And the cover-up method allows us to make 2 little equations to solve for the x and y intercepts. Now, the only thing with the cover method, it has to be in standard form, which this one is. So I would cover up the x, 6y equals 0. Cover up the y, I get 2x equals 12. So with that, I can divide my y-intercept as -2. And my x-intercept is 6. When you go to your graph, your x-intercept is 6, your y-intercept is -2, and you connect the dots. Whew. Okay. Okay, the next one, I have 8y equals 48. And then if I cover up the y, I have -12x equals 48. Divide both sides. So y equals 6. X equals -4. So my x-intercept is -4. My y-intercept is 6. And then I graph my line. Okay. Any questions on those ones?
I get confused on like.
We are going to talk about slope-intercept form. So remember that slope-intercept form looks like this, where B is your y-intercept and M is your slope. Okay, so in the first one, are you able to pick out your slope? What's our slope? 2. And what is our intercept? 4. So then what you should be able to do is go down to your graph and you start at the intercept at +4. And then your slope, if it's a whole number, just put it over 1. So you're going to go up 2 over 1, up 2 over 1. And I know those lines are very faded, so just do the best you can. On your quiz, you do need to use your ruler,
Just on this.
as long as you know. Okay. So the next one, is this in slope-intercept form?
No.
No, so what do I need to do?
We need to.
I need to subtract the 4x. We want the 4 and x to stay together. We just want them on the other side of the equation. So when you move the entire term, you're going to add or subtract. Now, I'm not going to write 7 minus 4x because in slope-intercept form, the x comes first. That 7 is positive, though, so I'm going to add it. So now I've got the equation of slope-intercept form. What is my slope?
4.
Negative 4. Yep, and my intercept is positive 7. Okay, so I'm going to go to positive 7. And then I am going to go down 4. 1, 2, 3, 4 over 1.
I'm confused.
Okay, what throws you off?
Like the graphing part.
Okay, so the last one here is a little bit more challenging because our y is not alone. So if we want this in slope-intercept form, I have to try to get my y alone. So who would I move first?
3x.
The 3x, that's right. So it is a positive 3x, so I need to subtract it in order to cancel it out. Okay, so I bring down what I have left. I have a 6y equals negative 3x, and then it's a minus 12, so I'm going to write that as a minus 12. And then, yep, if you want to split something up completely, we're going to divide. So we divide by a 6. Now what happens here, the y becomes alone. 3 over 6 is reduced to 1/2. And then a negative 12 divided by a positive 6 ends up being a minus 2. All right, I almost forgot my x there. So now I'm going to start at negative 2 on my graph. My slope is a negative 1/2, so that means I have to go down 1 over 2. Down 1 over 2. Graph your line. Okay. The last 3 problems, yep, they are good practice for us getting this in slope-intercept form. The first one is really close, but not quite. What do we need to do? Is y by itself?
Yeah.
Yeah, but slope-intercept form has mx plus b. So we just need to flip-flop these. Now, we aren't going to change their signs because we're not moving it to the other side of the equation. So the 4 stayed negative, the 2x stayed positive. We just wrote it differently. Okay. You only change it positive versus negative if you move it from one side to the other. Okay. The next one, our y is who we want to get alone. Who do I move first? Yes, we add 6x. Very good.
Would you add negative 6?
Nope, we are just adding positive 6 because if you have a negative 6 and you add 6, it gets to 0, which is what we want. And then I'm going to have 6x plus 24. And then my next step, yes, that's right. We need to divide by a negative 4. And when you divide everything by a negative. Okay, so a 6 over 4 turns out to be a negative 3/2. Okay, 3/2. And 3/2 x. And then 24. Give me 1 second. 24 divided by -4 is a -6. Okay. Then your last one, I put the y on the right-hand side, but we're gonna keep it there and we're gonna get it by itself. So that's okay if it's over here. So I want to move the x. How do I do that? Yep, subtract x. So I'm going to write minus. I like to put a 1 with my x. I still have stuff to do with that equation. Okay, now how would I get the y by itself?
Can you try and zoom
I
in?
actually can't, Maddie, right now because I'm spotlighted on my Zoom. Okay, we're going to divide. Yep. So this is -1/8 x plus 32 divided by 8 is 4. Now, sometimes it really bothers people if the y is on the right-hand side and we want on the left. So guess what? You can flip-flop everything as long as you don't change any of the signs. If we move the y to the right or to the left and everything else to the right, you have to keep everything like it is. So we end up with y equals -1/8 x plus 4.